and then share my pad. All right, y'all. So chapter 2 is going to deal with approaches to problem solving. All right, y'all. So first we're going to look at what we call the three-step problem solving process. All right, y'all. So the first step to solving a problem is to actually understand the problem. So think about what it's asking you to do. If you need to, draw a picture or diagram, and then think about what your solution should look like. So the next step is to actually solve the problem. Okay, so once you understand what you're looking at, um, obtain any needed information or data, keep an organized, neatly written record of your work, double check each step as you work to avoid errors. And y'all, the third step, explain the result. So, does it make sense? Um, Identify and understand any potential sources of uncertainty in your result. And write your solution clearly and concisely. All right, y'all. So, our three-step problem solving process. So, next time, we're going to go through some definitions with you. So, we're going to look at what we call units. So, units of a quantity describe what that quantity measures or counts. Okay, so units are like feet, pounds, grams. Okay. All right, we'll get into more different units in a little bit. All right, unit analysis. So, unit analysis is what I'll show y'all tonight. It's the process of working with units to help solve problems. All right, so I'm going to show you a little example where I would use this unit analysis. So for this example, you are buying 30 acres of farmland at $12,000 per acre. They want to know, what is the total cost? So, if we're thinking about this problem, they're asking about total cost. So we would expect that to be ended up in units of money. All right, y'all, let me let a few in real quick. All righty. All righty. So let me show you some unit analysis. I got 30 acres. So I'm starting with my 30 acres. I'm going to multiply that by the price per acre, which was $12,000 per acre. So per means you're dividing, okay? So when they say 12,000 per acre, we set that up like division. So this is 12,000 per acre. But y'all notice what happens when you do unit analysis like this. These acres here cancels with the acres there, so that my final answer will be in dollars. All right, y'all, so let me pull my chat up. Y'all got a calculator on you handy?
Yes.
All right, we need to multiply that 30 times 12,000.
360,000.
360,000. And y'all, that'll be in dollars. Since our dollars didn't cancel out, all it canceled out was our acres when we were multiplying through. All right, so we're happy it came out with the units we expected. All right, y'all. So here's some rules about unit analysis when we're solving problems. So unit analysis in problem solving. All right, the first thing, you cannot add or subtract numbers with different units. Okay, that means like you want your units to be what we call like terms if I'm going to add or subtract them, okay? So I cannot subtract 10 feet from 30 pounds because they're not in the same units, okay? Now, I can, but you can combine different units through multiplication, division, or raising the powers. And y'all, when I'm talking about raising the powers, we're talking about exponents. Like squaring something and cubing and stuff like that. Alrighty. You want to make sure that your answer has the units you expected. Right, if I'm looking at the area of a rug in my living room, I want it to be like square feet, not square pounds or square degrees or something like that. So make sure your answer has the units that you're expecting. All right, y'all. So next, we're going to look at some key words and operations with units. So I'll write the word, what its operation means, okay? So the key word and then its operation. So, like I showed you a while ago, per, when I had how much money per acre, per is a key word that means division. Just like miles per hour. Miles per hour is equal to miles divided by hours. That's how you find the speed in miles per hour. That's what it means. So to find my speed, I would take my miles, divide by the time, and get my actual speed. Of is a key word that means multiplication. Okay. So if I said what is 1/3 of 6, 1/3 of 6 means I would multiply 1/3 times 6. So 1/3 of 6 would equal 1/3 times 6. Finally, the next two deal with the power stuff. So if I square, that means I'm raising something to the second power. So feet squared is like feet times feet. So the exponents tell us how many times you multiply the feet times each other. A cube or cubic is raising to the third power. So feet cubed would be like feet times feet times feet. So a cube you would multiply the unit times itself 3 times. All right, y'all. Next, I'll get into conversion factors. I'll let y'all catch those up real quick. Alrighty, y'all. So let's look at these conversion factors. All right, y'all, let me let two in real quick. All righty. So a conversion factor is a statement of equality that is used to convert between units. So I'll show you some types of conversion factors. And then I put a sheet in week 3 for your Blackboard. Under week 3, I got a sheet you can actually print that's got a lot of conversion factors on it that'll be useful for helping you. But y'all, one conversion. So let's see if y'all know this. So I'm going to convert feet in inches. So my conversion for 1 foot would be 12 inches. So 1 day. So y'all, how many hours is in 1 day if I want to convert from days to hours? So how many hours would be in
24.
24? Oops. All righty, so 1 day would be 24 hours. I could also convert 24 hours. Each hour I could do in minutes. And then I could also convert minutes into seconds. Okay, so conversions get me from one unit into another one. So let's just do an example here. We're going to convert 9 feet into inches. All right, so we'll start with 9 feet. Now, our conversion was for every 1 foot was 12 inches. Now remember, I'm wanting to cancel the feet out and end up with inches. So I'm going to show you all a way that I do my unit conversion. 9 feet. Now I'm going to look at the ratio here. And I need to cancel the feet out. So down here, I'm going to put for every 1 foot, there's 12 inches. Now, everything on top gets multiplied together. Everything on bottom would get multiplied together. My last step would to be divide this, okay? So, notice what happens. The feet cancel out, and the only units that'll be left are the inches, which is what they wanted. All right, so calculator time. Multiply 9 times 12.
Is it 108? I just don't.
That sounds good.
Not.
108. And since we canceled out our feet, Our inches are left as our units. So, y'all, that's what they're talking about on this unit analysis. You set things up so that you can cancel out the units that need to cancel out, and then you want your answer to end up with what they're asking for, okay? So let's try this one. Now, this one will take a few different conversions, but I want to know how many seconds are in 94 days. So I'm starting with this 94 days. So the easiest way to start this, we know that one day is 24 hours. So I'm going to cancel the days out. So I'm going to do one day is 24 hours. So y'all look here, the days now cancel. But they didn't want me to end up in hours. So now next, I'm going to convert from hours to minutes. Okay, we got to keep converting down until we get this into what they wanted, seconds. All right, y'all. So for every 1 hour is how many minutes?
60.
All right, so that'd be 60 minutes. So now look what happens. The hours are going to cancel. But y'all, we still need to keep going because we need this in seconds and not minutes.
Right.
So now we'll cancel the minutes by telling how many seconds are in every minute. So for every 1 minute,
60 60 seconds.
that'd be 60 seconds. So now the minutes cancel. Now remember, all of this on top, all these numbers get multiplied, and then we would divide by all the numbers on the bottom. But y'all, all I got on bottom is 1 times 1 times 1, so that ain't hurting nothing. What we need to do is multiply 94 times 24 times 60 times 60. Whoa, y'all, that's a lot of seconds now.
Right.
I did this on my calculator, so if y'all are punching this in, y'all should be getting 8,121,600 seconds. Final answer. So I guess 94 days, that's about 3 months. So in 3 months, we went through over 8 million seconds. All right, y'all. So y'all good on those?
Yep.
All right, so let's look at some of these conversions with units raised to powers. All right, so 1 yard equals 3 feet. So how much is 1 yard squared? So y'all, to find that, 1 yard squared is 1 yard times 1 yard. But we said up here, a yard was 3 feet. So if I replace each of these yards with 3 feet, I get 3 feet times 3 feet, which means 1 yard squared, I would multiply 3 times 3 and get 9. And then feet times feet gives me feet squared. Remember, exponents tell me how many times something got multiplied by itself. So a conversion for 1 yard squared would be 9 feet squared. All right, y'all. So an example of this. You carpet a room. That measures 12 feet by 15 feet, making the area so they found the area by multiplying 12 times 15. But when they did that, the area of 180 square feet. So just like y'all do if you wanted to measure how much area was in your living room, you would measure the length times the width and get your square feet, okay? Now, carpet is sold by the square yard. So they don't sell carpet by the square feet, they sell it by the square yard. So they want to know how many square yards of carpet do you need? All right, y'all. So this is where we know we're starting with this 180 square feet. So 180 square feet would be feet squared. Now we figured out a conversion right here. Square yards were equal to 9 feet squared for every square yard. So since I'm wanting to cancel the feet out and end up in yards, I need to put the 9 feet squared on the bottom and the yard squared on the top. And y'all, that ends up in yard squareds like I need. Notice the feet squared canceled out. So you always want to make sure that you put the unit you want to cancel either on bottom or top, whatever it takes to cancel it, okay? Now, you multiply the 180 times 1 on top. Since the 9 is on bottom of the line, we would take the 180 and divide by 9 and end up in square yards. And y'all, what's that? 180 divided by 9, that's what 20 square yards. All right, so we're going to do the same thing with a cube. All right, so if we're going to deal with cubes, we need to figure out their conversion. So we know that 1 yard equals 3 feet. So 1 yard cubed would equal 3 feet times 3 feet times 3 feet. Because remember, a yard cubed is a yard times a yard times a yard. And we said each yard was 3 feet. So that 1 yard cubed, 3 times 3 times 3 is 27. Feet times feet times feet is feet cubed. Okay, so when you're dealing with cubes, you're dealing with the volume of something. The length times the width times the height. Okay? So y'all, let's go to the next page and we'll do an example dealing with cubic. Alrighty, so this example wants to know how many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide by 4 feet tall. So cubes deal with volumes more, like I said. So first of all, we're going to find the volume. Once we find the volume, we'll be in cubic feet. Okay, and then we'll convert that into cubic yards. So volume is length times width times height. So let's figure that out. So they told me it was 20 feet long. So 20 feet times 3 feet wide times 4 feet tall. All right, y'all, multiplying all this. 20 times 3 is 60. 60 times 4 is 240 cubic feet. So we know the volume in feet cubed. Now we're going to convert that into cubic yards. All right, so we're starting with 240 cubic feet. Now, y'all won't go. We said there was, since I'm canceling out the cubic feet, I'm going to put my unit down here. 27 cubic feet equaled 1 cubic yard. So see here, y'all, these units for feet cubed are going to cancel. I'm going to be left in the cubic yards like they wanted. All right, y'all. So now we divide. And I think on this one we would leave it 1 decimal place. So let's take that 240 and divide by 27. All right, so 240 divided by 27 gives me 8.8888. I'm going to round it 1 decimal place. So that'll be 8.9. And then that'll be left in cubic yards. Now, MATLAB on the answers, it'll tell you how far to round your answer. When you're doing the problems. All right, y'all, next, we're going to get into currency conversions. Now, on this, they'll give you a chart usually. So, currency conversions. So I'm going to show you a table. These are what you call exchange rates from one currency into another, like dollars to euros, pounds, yens, and all those. So the British pound. So each dollar is worth 1.624. So these are the American dollar conversions, okay? You got the Canadian dollar. That is 1.005 US dollars. The European euro. And y'all, they'll have charts with these on it that you'll use. That is 1.320 US dollars. We got the Japanese yen. That is 0.0120 US dollars. And then the Mexican peso. It is worth 0.07855 US dollars. All right, so let me show you an example of that. Well, we're going to convert from Canadian dollars into US dollars, and we'll use our little conversion right there. And so a gas station in Canada sells gasoline for CAD 134 per liter. So that means Canadian dollars. They want to know, what is the price in dollars per gallon? And then the conversion for liters to gallons, 1 gallon equals 3.785 liters. And y'all, this will be on that sheet I got in Blackboard under week 3, the unit conversion. It'll have the gallons and the liters on that, okay? Actually, let me see. Let me pull that up real quick. so that y'all know what I'm talking about. I'm trying to get it to open. All right, y'all, hang on 1 second. Let me grab something. Come on. Are y'all seeing the unit conversion sheet? Is that showing on screen?
No.
No.
All righty, hang on. Let me stop my share and start over. All righty, let me get my share going back. All right, y'all seeing the sheet now?
Yeah.
All right. So y'all, this is in week 3 folder in Blackboard, and this has got a lot of the conversions you're going to be doing. So over here on the left, you'll see it converts a lot of stuff. Now the U.S. metric, they go from liters to gallons, but if you notice on the left side, it's got from American to metric, and there's that 1 gallon equals 3.785 liters. So those are helpful conversions that'll help you on your homework, okay? Alrighty, so we're going to start with 134 CAD. So this 134 Canadian dollars per 1 liter. So I got 2 conversions I got to do on this. I got to convert from Canadian dollars to US dollars. I got to convert from liters into gallons because they want this answer in dollars per gallon. So the first thing I'll do, I'm going to fix this Canadian dollars into US dollars. While ago, we said that for every 1 Canadian dollar, that was worth 1.005 US dollars. So that cancels out the Canadian dollars and leaves me in American dollars. Now I'm going to convert from liters into gallons. So remember, liters has to cancel. So since this liter's on the bottom, my liters will be on top and my gallons will be on the bottom. So 3.785 liters for every 1 gallon. So now these liters will cancel. And y'all, that's the trick on this unit analysis. The units you gotta cancel has to be 1 on top and 1 on bottom. All right, now let's go multiply that out and see what we get. All right, so I'll clear that. So everything on top gets multiplied. 1.34 times 1.005 times 3.785. Now on the bottom was 1 times 1 times 1. So we don't have to worry about the bottom. So y'all, let's see. I'm going to round this 2 decimal places like money. So the 9 has a 7 after it. So the 9 is going to round up to a 10, which will make that a 0, and then carry my 1. So that'll round up into $5.10. And my money will be left in dollars now, since dollars was the only unit left on top. So y'all, they're a little tricky sometimes. You just got to try to match them units up that you need to cancel out, okay? All right, so how are y'all with the metric system? Because that's coming up next. All right, y'all, so in the metric system, what is our unit for length? And y'all, that is the meter represented by a M. Mass. So length is how long stuff is. Mass is how heavy something is. So for mass, we use the kilogram. That is a kg. Now, smaller amounts, you're going to use what, a gram and stuff like that. Okay. Milligrams. Time is the same. We use the second, represented with a S. And then volume. We use the liter. So the volume is liter in metric. English was the gallon. Now, liter, we use a capital L. So, y'all, these are the units for length, mass, time, and volume. But y'all remember the metric system uses definitions for different place values. Okay, so I'm going to give you a chart. So we'll just use meters as our middle. So below meter, that's the common unit. We go by tenths. If we go upward, we're multiplying by 10. Okay? So right under the meter, you have the decimeter. That is 1/10 of a meter. Okay? And then I'll go the other direction. So under the decimeter, centimeter. A centimeter is 1/100th of a meter. So this is how much they are compared to the meter. Milli. Milli is 1/1000th. So see how they're going by powers of 10? Further we go. All right, micro. Micro is 1/millionth. Of a meter. All right, y'all. So the final two, a nanometer would be 1/billionth. So that's got 9 zeros. All right, then finally on the bottom side is your picometer, and that's 1/trillionth. So that's got 12 zeros. Now, we're not going to have to worry about these that much. We're just showing you what these abbreviations mean as relevant to the meter. So this is the small sign. These are getting smaller as we go down. Now, let's go above the meter. First, we got the decameter. So DECA, decameter, that is like 10 meters. Then you got the hectometer. Well, y'all, that is like 100 meters. So instead of saying, hey, that race was 100 meters, they say, hey, that race was 1 hectometer. All right, you got the kilometer. A kilometer is 1,000 meters. Mega meter is like 1,000,000 meters. Giga. So y'all hear stuff like gigabytes and stuff. So giga is 1 billion. So these are getting larger as I go up. And y'all, the last one is tera. And that is 1 trillion. So 12 zeros. So they're larger as we go up on this list. Okay, so definitions. The symbol for tera is a capital T. Symbol for giga is a capital G. Mega is a capital M. Kilometer is a small k. Hectometer, they use a small h. And then deca, they use a DA. Now for the smaller ones, deci uses a D. So that's why deca is a DA, because the D is already taken by the decimeter. Centi is a C. Milli is a M. Micro uses either the micro symbol or MC. Nano is an N, and then pico is a P. All right, so let me show you an example of using this table right here, okay? All righty, so for this problem, we're going to convert 2,759 centimeters to meters. Okay, so we're starting with 2,759 centimeters, which I can denote as a cm for centimeter. Now, let me go back to the chart. If a centimeter is 1/100th of a meter, that means that there is 100 centimeters for every meter. There's 10 decimeters for every meter. 1,000 millimeters for every meter. Okay? So look what we're going from. We're going from centimeters to meters. So for every 100 centimeters, we get a meter. So, y'all, we just had to end up in meters, it looks like. So my centimeters are canceling. I'm going to end up in meters. So we need to take that 2,759 divide by 100. So y'all, if you take 2759 divided by 100, y'all should get 227.59 meters. Oh, no, I'm going to play with the homework with y'all in just a second. Um, so we're going to look at temperature units real quick. All right, so you got the Kelvin, Celsius, and Fahrenheit. Okay. Now, 0 Kelvin, which is 0 K, is what we call absolute zero. So the coldest possible temperature you can actually get. And 0 Kelvin is equal to negative 273.15 degrees Celsius.
That is cold.
That is cold. That's when they start freezing stuff like roses and they just shatter like glass and stuff, so definitely cold. Alrighty. Celsius, water freezes at 0 degrees. All right, in Celsius, 100 degrees is the temperature where water boils. All righty. Fahrenheit, water freezes at 32 degrees. So y'all, when does water boil in Fahrenheit? And that's a pretty high number too. That's what, 212 degrees Fahrenheit is where water boils. All right, so some conversions. Celsius to Fahrenheit. So this is how you convert from one temperature to another. So you multiply by 1.8, then add 32. To go from Fahrenheit to Celsius, you subtract 32 first, then divide by 1.8. So it's sort of the opposite of this one. Celsius to Fahrenheit, you multiply by 1.8, then you add 32. If you're going the other way from Fahrenheit to Celsius, you subtract the 32 first, then divide by 1.8. So my formulas would be, for F, would be 1.8 times the Celsius temperature plus 32. To go the other way, Celsius would equal your Fahrenheit minus the 32, divide that by the 1.8. All right, then y'all, let me put the last two little conversions here. Celsius to Kelvin. Now, you don't use this Kelvin scale a lot, but to go from Celsius to Kelvin, you add 273.15. So that K equals C degrees plus 273.15. And to go from Kelvin to Celsius, well, if you're adding 273.15 to go from Celsius to Kelvin, to go from Kelvin to Celsius, you're going to subtract 273.15. So Celsius will equal K minus 273.15. All righty, y'all got any questions? So let me get something set up because I want to show y'all sort of like what the problems will look like on your homework. So I got to pull MATLAB back up real quick. All right, so I'm going to share the screen to get into the homework now. And just sort of go through some of these with y'all, see what y'all are going to do with them, okay? All right, so let's go to question 1. So what did we say the word of meant? Adding, multiply, or divide?
Multiplying.
Multiply. So y'all just going to put multiply by there. And then check your answer. All righty. How much would a person pay for 12.6 pounds of bananas at a price of $2.19 per pound? So let me write what we got. We got 12.6 pounds of bananas. At $2.19 per pound. All righty, so let me show y'all what I would do to that. All right, so let me see. I can't tell if I'm on the page yet. I need to pull my page up a little. All righty, so y'all, what we're looking at here, we're starting with 12.6 pounds of bananas. Now they told me the price over here was $2.19 per pound. So that would be $2.19 per pound. So notice what's happening. The pounds are going to cancel, and I'm going to end up with the dollar amount, which is what I needed. Alrighty, so we're going to multiply that. And MATLAB says round to the nearest cent, so that's 2 decimal places. So y'all, if I take 12.6 and multiply by 2.19, that equals 27.594. But remember, they want me to round it 2 decimal places. So that's where that 9 is. So remember, if 9 is in the place I'm rounding to, would I round that 9 up or keep it the same based on that 4?
You'll round it up and carry the 1.
Oh, you're close. But remember,
You'll keep it the same.
I keep it the same. Because remember,
This is less than 6.
it's got to be 5, 6, 7, 8, or 9 for me to
Yeah,
round
less
up.
than 5. Right.
Uh-huh. All righty. So then that would stay the same. It'd be 27.59. All right, so that's what we would put in MATLAB. So let's go put that in. So 27.59 we said. And then see, this one says dollars or pounds. What am I picking?
Dollars.
Dollars.
Dollars, right? Because we're paying something, right? There you
Right.
go. So you would put in the amount, pick your dollars, and then we moving on. All right, so this one says a person is paid $430 for 27 hours of work. So what is the hourly wage?
You'll divide 430 and 20.
That sounds good. There you go.
I agree.
So let me see how I would actually set that up doing my analysis. So we know we got $430 for 27 hours of work. And y'all perfect. You're going to divide. That way you'll end up with how much money
60.
per hour, right?
Right.
All right, so let's see. We're going to round this 2 decimal places. So 430 divided by 27 gave me 15.9259. And that's going to be dollars per hour. But remember, they want me to round 2 decimal places. So the 2 is in the second decimal place. Am I going to
Oh,
round
okay.
that 2 up or keep it the same?
Keep it the same.
Oh, what's after it?
Round.
Okay,
Yeah,
okay.
round it up.
So that 5 means that 2 is going to be, so we're
A
going to,
3.
so 15.93 per hour. So in MATLAB, you got to pick the units again, I think, on that. So what we get? 15.93, y'all said. And then dollars hours or dollars per hour?
Dollars per hour.
Okay, dollars per hour. There you go.
Yeah.
And y'all check that answer. So they're not bad. You're either going to multiply and divide on these.
What is the total cost?
So what is the total cost of 1.6 cubic meters of soil if it sells for $34 per cubic meter? So you multiplying or dividing that?
I think divide.
Multiply. Yeah.
Okay, so it's 34 per cubic meter. Definitely, good job. You're going to multiply that. So y'all multiply 34 times 1.6. And it says type an integer or decimal. If you type that in and multiply, you only get 1 decimal place anyway. So are y'all getting like a 54.4?
54.4.
Yeah.
Okay, so 54.4. And since it only had 1 decimal place, you put everything on it. And that makes sense because if 1 cubic meter is 34, 1.6 is almost half of another cubic meter, a little more than half. So you know it's going to be a little larger. There you go. You know, that's a trick on these. So we'll move down. Let me find some different problems for us. All right, let's check this one out. Let me write this one down. Your car gets 34 miles per gallon. How much does it cost to drive 350 miles when gasoline cost
310 per gallon.
310 per gallon? All right, so a little more work on this one. All righty, so we know we're going 350 miles. So I'm going to start with that 350 miles. All righty. Right here it's telling me my car gets 34 miles per gallon. Now remember, I need to cancel the miles. So I'm going to come down here and do 34 miles per gallon. So the miles are going to cancel. Because I'm looking for how much it's going to cost. So I'm expecting my units to end up as money only. Now, to go from gallons into my cost, it's telling me my gas costs $3.10 per gallon. So I need the gallon to cancel. And I get what? $3.10. All right, so notice how them gallons cancel. All that's going to be left is the money. So see what we're doing, 350 miles, you got 34 miles per gallon. So if you divide 350 by 34, that'll tell you how many gallons you gotta use. And then for every gallon was 310. So you ought to do this one. You're gonna multiply the top together and then divide by that 34 on the bottom. So you would have 350 times $3.10. Get that answer, and then divide that by the 34, and we should get 31.9117. But let's see what MathLab wants us to round that to. Round it to the nearest cent, which is 2 decimal places. So that 1 behind the 9. Am I going to keep that a 1 or am I going to change that to a 2? So since I'm looking at the 1
Keep
for
the
my,
one.
Leave it the same.
leave it the same because since that number after it was a 1, we're going to leave it the same. And that'll be 31.91. So if you get 34 miles a gallon and your gas costs $3.10 per gallon, for $31.91, you can drive 350 miles. All right, y'all, so you'd go put that in. Now you see, MathLab's already got the money symbol there, so you don't have to put the money symbol. You just got to put the amount we got. All righty. Let's convert 15 feet to inches. All righty. So we're converting 15 feet, so I'm going to start with 15 feet. Now we got a conversion that'll go straight from feet to inches. So how many inches did we say was in a foot?
12.
All right, so for every 1 feet, that was 12 inches. Good job. So see, my feet will now cancel. I'm going to be left in inches like we needed. All right, y'all, so we got to figure out what 15 times 12 is.
180.
So that's going to give me 180 inches. Good job. So y'all, that's what we're going to put in MathLab here. And see, they've already got the inches, so y'all just have to put in the 180. All right, so that'd be doing about the same. So let's try that. Convert 15 minutes to seconds.
15 times 60 times 60.
Let's see. So let me share. All right, so you started with 15 minutes. All right, so can you go from minutes to seconds? How many seconds is in a minute?
60.
Okay, so every 1 minute is 60 seconds. Hey, and I think that's got us what we need, right? These minutes cancel. Now we're left with seconds. So multiply that 15 by 60 and see what we get.
900.
So that'll be 900. And then seconds is our units we got left. Boy, you don't think of time. That's a lot of seconds in 15 minutes. You just don't think of how big they are. But think if that was 15 hours. That would be humongous amount of seconds.
It'll be 15 times 60 times 60.
Uh-huh. That's pretty big then, right? So whatever 900 times 60 was. All right, so y'all said what, 900 on that one? And then that's got the seconds in it, so we would hit enter and move on. Oh, let's try this one because this will get us a big number, I bet. Convert 4 years to hours. And I guess they're saying, forget about them leap years. We're not worried about that 29 days in February this time, okay? So we're going to need a few conversions on this because we're starting with 4 years. And we're going to hours. So I think I would first start with figuring out how many days are in a year.
365.
So for every
Mhm.
1 year, that is 365 days. All right, but I'm not wanting days, I want hours. So can I
Right.
go from days to hours?
Mm,
You got to see how many days is in 4 years.
Well, don't worry about that because your years are canceled now.
Then you go to weeks, maybe?
So what I want you to do is since I'm in days here, can you relate days and hours?
24 hours in a day.
There you go. So I'm going to put the day down here to cancel the days. So 1 day is 24 hours. So see now the days cancel and I'm in the unit I needed. Now if they wanted minutes, I would go from hours to minutes and then minutes to seconds if they wanted that part. So now all we got to do is multiply 4 times 365 times 24. Oh, that's quite a bit. Did y'all get that?
35,040.
There you go. And that'll be hours. All righty. So let's put that one in. So 35,040. And they've already got the hours there. So you just put in the number and move on. All right. So let me. So on that one, they're giving you the exchange rates on the right side over there, sort of like that one I did a while ago. You're converting 301 Canadian dollars to US dollars. So that Canadian dollar and then dollars per foreign. So we would use that 0.7828 on that one. So y'all let me start with that. So we got 301 Canadian dollars. That's CAD. And we're going to convert that to US dollars. And let me put that right up there, 0.7828. All right, so you're starting with 301 Canadian dollars. So for every Canadian dollar, 1 Canadian dollar was 0.7828 US dollars. So now I'm getting that off that table they gave me. Right there, okay? So the Canadian stuff cancels. So multiply that, and let's see, we don't know what units they wanted me to stay in on that one. Let me find it real quick. Looks like they're doing 2 decimal places. So 301 times 0.7828. So y'all, I'm getting this 235.6228. So I'm rounding 2 decimal places. That's where that 2 is. Are you leaving it a 2 or rounding it up?
Leaving it a 2.
Leaving it a 2. So that'll end up 235.62. Okay. All right, so that'll be the 235.62. And y'all, that's the way you're going to do them problems right there. All right, so let me see what some of these are down here. All righty, so these lessons right here, I'm going to go over on Thursday. So we will pick up question 11 through 18 on Thursday after I show y'all how to work with those, okay? So for tonight, if you want to do homework, work up until problem 10. And then we will pick up starting with number 11 on Thursday. Alrighty, so we'll finish out that little bit Thursday and then play with that section 3 stuff. Alrighty, y'all. Any questions?
None over here.
Yeah, so just start out up there working with them units. Then, like I said, Thursday I'll show you how the easy way to get them answers on that 10 to the 4 times 10 to the third stuff. And then section 3, let me see, 3 deals with big numbers, small numbers, and trying to guess what we think is right or wrong on those. So we'll look at like what we call the magnitude of numbers. And it deals with them exponents. Remember, 10 to the 6 is like a million. So would it be possible to read a book that's like 10 to the 8th? So that kind of questions is in 3. All righty, y'all. So I'm going to stop our record.